We're led to believe that the universe is basically understood. Galaxies, gravity, the Big Bang, just a matter of filling in the details. But most of the universe is invisible. Dark matter, dark energy, as we discussed in the previous appendix, unknown origins, unknown endings. When you actually look at it, cosmology becomes less like a finished map and more like a confrontation with mystery itself. How can we claim to understand reality when most of it is missing? Physics, Consciousness and Reality, Dickie Dredd, Nigel Adams. And this is an appendix number 3. So we're taking a slight detour. We'll get back on the main book tomorrow, or in the next video. Appendix 3, Cosmology and the Shape of the Universe. So cosmology is the study of the universe in its entirety, its origins, its unfolding, and its possible destinies. Unlike most sciences, cosmology cannot be tested through repeatable laboratory experiments, or not usually. It deals with one case of everything. To do so, it blends astronomy, mathematics, physics and philosophical imagination. From the earliest myths to the most advanced computer simulations, cosmology has been an attempt to make sense of the night sky and the place beneath it. The first cosmologies were woven into stories. Mesopotamian sky gazers read the heavens as messages from the gods. Egyptian myth imagined the sun swallowed each evening by the goddess Nut, only to be reborn on the next dawn. The Vedas sang of cosmic sacrifice and renewal, while the Chinese pictured the world hatched from a primordial egg. These myths carried meaning as much as mechanism, rooting human life in the rhythms of the cosmos. Mahayana Buddhist sutras speak of a virtually infinite number of world systems coming into existence, growing, plateauing and decaying into nothingness over unimaginable periods of time. Greek philosophy moved the debate towards rational models. Pythagoras sought harmony in the heavens, whilst Aristotle conceived of crystalline spheres carrying the planets round a central earth. Ptolemy's refinements made the geocentric model dominant for over 1,000 years. The Copernican revolution then broke that spell. Earth was no longer the centre, but a planet among others. Galileo's telescope revealed moons circling Jupiter and blemishes on the Sun. Kepler discovered elliptical orbits, and Newton provided the law of universal gravitation, showing that one set of principles governed both falling apples and orbiting planets. The universe became mechanical, ordered and mathematically precise. 20th century physics re-enchanted the cosmos by showing how strange it really is. Einstein's relativity replaced Newton's invisible forces with curved space-time. Edwin Hubble discovered the expansion of the universe, leading to the Big Bang model, a hot, dense beginning approximately 13.8 billion years ago. Supporting evidence came in the cosmic microwave background radiation, the abundance of light elements, and large-scale galaxy surveys. Modern cosmology is powerful but incomplete. Dark matter and dark energy dominate the equations, yet remain undetectable in direct form. See, that was in fact Appendix 1, and we covered that earlier. Inflationary theory, proposed to explain the uniformity of the cosmic microwave background, suggests the universe underwent an unimaginably fast expansion in the first fractions of a second. Quantum cosmology speculates about what happened before the Big Bang, though the very term may be meaningless. Multiverse theories proliferate, some arising naturally from inflation, others from string theory, suggesting our cosmos may be just one bubble among countless others. Outstanding questions abound. Why did the universe begin in such a low entropy state? Why do the laws of physics take the form they do? What is the true nature of dark energy? Will expansion continue forever, slow to a halt, or reverse in a big crunch? For this book, the relevance of cosmology lies not only in its science, but in the parallels with consciousness. Both present mysteries that resist reduction. Just as we do not know why neural processes give rise to experience, we do not know why the universe exists at all, or why it is structured in such a way as to allow complexity and awareness to emerge. Both questions leave us confronting the limits of explanation. Some thinkers push the connection further. Panpsychism proposes that consciousness is not confined to brains, but is a fundamental feature of matter. We'll cover that in a later section. Cosmopsychism goes further still, Perhaps the universe itself is conscious, with our individual minds as partial expressions of a larger awareness. From an Eastern perspective, this is less radical than it sounds. Hindu Vedanta speaks of Atman and Brahman, the self and the cosmos, as ultimately one. Buddhist thought sees mind as woven into dependent origination, not as an isolated spark, but as part of the whole fabric, and we'll cover that later. Taoism imagines the Tao flowing through all things. We'll cover that later. In modern physics, similar resonances appear. John Wheeler's slogan, "It from bit," hints that reality arises from information, and we covered that earlier. And if information and consciousness are entangled, then awareness may be embedded in the very ground of being. Stephen Wolfram's physics project imagines the universe as a vast computational process unfolding from simple rules. In this view, consciousness may not merely emerge within the universe, but may be a feature of its generative logic, inseparable from the patterns that give rise to space-time itself. Whether or not one accepts these ideas, the symbolism is potent. To see the universe as conscious is to refuse to treat it as an inert machinery. It is to recognise participation rather than detachment. We are not passive observers standing outside a cosmic play, but embodied centres of awareness through which the universe knows itself. In this light, cosmology is not just a map of galaxies, but a mirror held up to our mind. The danger is always anthropomorphism, projecting human qualities onto the cosmos. Yet the opposite risk is to imagine the universe as entirely lifeless and mechanical, a view that is itself an anthropocentric projection rooted in industrial habits of thought. The balance lies in openness. To explore cosmology rigorously, while allowing that our categories of matter and mind may be too narrow to contain the truth. The broader themes of this book, perception as interface, consciousness as fundamental, illusion as a survival strategy, all meet here. Cosmology shows us a universe in which most matter and energy are hidden, just as consciousness shows us a mind in which most processes are unconscious. Both suggest that what appears is only a surface. Both invite humility and wonder. If the universe is conscious, then every star, every galaxy, every quantum fluctuation is part of that vast awareness. If not, then at least the question reminds us of the strangeness of being, that a cosmos of particles and fields has produced creatures who can ask such questions at all. Either way, cosmology reveals that we live in a reality richer than our stories, stranger than our models, and more mysterious than we can possibly think. The deeper cosmology goes, the stranger existence becomes. And if that's true, then the universe may be far more than inert matter drifting through empty space. Which means the problem isn't just how the universe works, it might be whether consciousness and cosmos were ever truly separate to begin with. And if that's the case, are we observing the universe, or is the universe observing itself through us? Next up, we'll get back onto the main parts of the book, where we're going to be talking as consciousness at the frontier.